Yes, we look at a question on quadratics, and the question is solve solve x squared minus 11x plus 29 raised to power 6x squared plus x minus 2. Everything is equal to 1. So we are expected to solve, and what we are told is that x squared minus 11x plus 29, if raised to power this, then we get 1. And so we are required to solve for x. So this is how we proceed. Solution. We first take a case that we can only have 1 if this base is 1. If the whole of this is 1, the base is 1 and this is 0. So if that is the case, that is 1. Okay, so I will say I can have case 1 where a raised to power 0 is 1. A raised to power 0 is 1. That is if I let all this to be a. If I let this to be a, then a raised to power 0 will be 1. So in which case this is equal to 0. So I'll say that now 6x squared plus x minus 2 is equal to 0 using that. And this is quadratic. So we look for two numbers whose product is positive 1 and sum is negative 12. It's easy to see that that should be 3 and 4. So I say here 6x squared plus 4x minus 3x minus 2 is equal to 0. So I can factorize here 2x. No, let me just rearrange for convenience. This would then mean that 6x squared minus 3x plus 4x minus 2 is equal to 0. And so I factorize 3x. If I factorize 3x here, this is 3x, then this is going to give me 2x minus 1 plus 2 into 2x minus 1 is equal to 0. So that means that I have here 3x plus 2 in bracket 2x minus 1 is equal to 0. That should then mean that x is minus 2 over 3 or x is half. Those are the scenarios if we take the first case, minus 2 over 3 or x is half. So that is the case where we take a raised to power 0 is equal to 1. Now, another case that we may take that would still imply that, so in which case here means that this a can be any number. It doesn't necessarily have to be 1. It can be any number. And we know that any number raised to power 0 gives us 1. So that's the first case we have here. The second case we have is that this is 1 and we raise it to any power. So case 2 is where we say 1 raised to power b is 1. 1 raised to power b is 1. Now I'm making use of indices. Now that then should imply that the whole of this is 1. The whole of this is 1. So I say this means that x squared minus 11x plus 29 is equal to 1. That one there is equal to 1. Is equal to 1. I bring this end, so that means I have x squared minus 11x plus 28 is now equal to 0. Plus 28 is equal to 0. I'm looking for two numbers whose product is 28 and sum is negative 11. That has to be 4 and 7. So here I have x squared minus 4x minus 7x plus 28 is equal to 0. So I can factorize x here. I have x. So it's x minus 4. Then here I have again minus 7 into x minus 4 is equal to 0. So that if I expand this, I end up with this. So this means that I have x minus 7 into x minus 4 is equal to 0. That means that x in that case should be 7 or 4. X will be 7 or 4. So we have, just a minute. Yeah, x is 7 or 4. Then what other possibility do we have? Do we have another possibility where, yes, we can consider a case where another possibility, let me call it case 3. This was case 1. This is case 2. So case 3 is where we say minus 1, c minus 1 squared is positive 1. So we give it a b to allow it to become any value that we want. Yeah, so that's another possibility, that negative 1 is squared to a big it's squared to a big value. So that's why we are putting 2 here and multiplying by 2. This b allows us to consider possible powers, many powers as can possibly be seen. So, but the fact remains with this expression is that this is negative 1. Now in that case, that's what it means. So I'll say that x squared minus 11x plus 29 is equal to negative 1. Negative 1. That should mean that x squared minus 11x plus 30 is equal to 0. Plus 30 is equal to 0. And if that is so, I have this place. Oh, the question I've wrapped this. Okay, I'll find it. Now, okay. So I have this. I need to see what it looks like. But then I need two values whose product is 30 and sum is negative 11. That's 6 and 5, yeah? Again, we have 6 and 5. So I have x squared minus 6x minus 5x plus 30 is equal to 0. So that means x into x minus 6 minus 5 into x minus 6 is equal to 0. That should then mean that x minus 5 or x minus 6 is equal to 0. And therefore, x is 5 or 6. X is 5 or 6. So we have three cases. The first case we saw, the one I've just rubbed, and it was the case where a raised to power 0 is equal to 1. Second case is where 1 raised to power b is equal to 1. Third case is this. So we say let us substitute these values that we have. If we substitute, because at first we had this, so we could substitute these values into the power. We also have this, and which one? The ones that I've just rubbed. But what this implies is that if it began with a negative and it's a positive, it means this has to be raised to some power. So we are expecting, what we say is that we are expecting a substitution that gives us an even number. So we'll try first, let's say x, we first take, we first take 5 and substitute 5 in the power. Now the power I've rubbed, but the power was something like that power was something like 6x squared minus x, no, plus x minus 2. That was the power that we had. So if I put 5 here, what do I get? I start with when it's 5. When x is 5, then 6x squared plus x minus 5 becomes when we put 5, it should give us 153. And when x is 6, it gives us, the whole of this gives us 220. That you simply get by when x is 5, you square, that's 25 times 6 plus 5 minus 5 gives you this. It should be, oh, it's minus 2. This is minus 2. Yeah, it's minus 2. There's no 5 there. Yeah. So that, yes. And then if you substitute x here again, that will be 36. 36 times 6 plus 6 minus 2 gives you that. Gives you 220. Yeah. Just substitute when x is 5 and when x is 6. You will get these values. And we pick the one which is even. So the one that gives us an even number is when x is 6. When the x is 6, that gives us an even number. So real number solutions, solutions to our problem are, real number solutions to our problem then are, they are the values that we have worked out. We first found x to be negative 2/3. We also found x to be or a half, or it can be 4, or it can be 6 and 7. Now we are saying those gives us real number solutions. So let's try to substitute those values, and we'll see that they give us a number which is even, all of them. So that is the answer to that particular question. So up to there, we are done with it. See you in my next video.